my name is Meisher Bin. It's a great honor to be here today to share our work, object-oriented anchoring and modal alignment in multimodal learning. Modality alignment has been of paramount importance in recent developments of multimodal learning, which has inspired many innovations in multimodal networks and pre-training tasks. In this paper, we develop a multimodal learning method that integrates the advantages of modality alignment from single-stream networks into the dual-stream network by introducing object-oriented anchors to bridge alignment between image and text modalities. Extensive experimental results validate the effectiveness of our method. The presentation will be divided into following 4 parts: motivation, method, experiments, and conclusion. Single-stream networks can effectively leverage self-attention mechanisms to facilitate modality interactions, but suffer from high computational complexity and limited applicability to downstream retrieval tasks. In contrast, dual-stream networks address these issues but ignore the significance of modality alignment. Object-oriented anchors are generated effectively and circumvent the need for object detection boxes as previous region-based approaches, while also preserving explicit semantics for modality interactions. We also design fine-grained token-level asymmetry alignment between modalities and multiview mining to promote modality alignment. Extensive experimental results validate the effectiveness of our method, demonstrating that the proposed method outperforms most previous arts in various downstream tasks. Our model includes an image encoder, a text encoder, and a multimodal fuse encoder. To train from noisy web data and facilitate single-modal self-supervised training, we maintain a momentum version for each encoder during training. The image patches, embedded by linear mapping, are applied with position encoding to obtain image tokens. For the text, we tokenize and embed text following BERT. Subsequently, image embeddings are processed through an object generator to obtain image region objects. Finally, we concatenate image embeddings, region object embeddings, and text embeddings, and input them into the multimodal fusion encoder for alignment and interaction to learn joint modal representations. To address the inconsistency between training and testing for the image encoder, we also introduce fine-grained alignment and other supervisions. The motivation for using region objects is to employ them as anchors to bridge image and text alignment. The introduction of region objects is similar to the image, tag, and text triplets in Oscar and VinVL, where tags are obtained from bounding box labels output by a pre-trained object detector. Our region objects circumvent the need for a cumbersome pre-trained object detector and are directly obtained from image tokens. Unlike Philip, we adopt a more direct approach by identifying correspondence between tokens from 2 modalities. This asymmetric correspondence can be conveniently solved through optimal transfer, but we extend it to object anchors. For the 3 paths of information, image, text, and object, we calculate the optimal transport loss for every pairwise combination. To allow textual descriptions to encompass different perspectives of images, we introduce other texts that are most similar to the current image from the dataset as positive samples. We evaluate our proposed method on 5 downstream tasks, including image text retrieval, visual question answering, visual entailment, natural language for visual reasoning, and visual grounding. The image text retrieval task comprises 2 subtasks: image-to-text retrieval and text-to-image retrieval. We evaluate our method on the publicly available datasets, Coco and Flickr. We also compare methods that use more data, such as Align, which demonstrates the effectiveness of our proposed method. We further evaluate our method on VQA, NLVR2, VE, and grounding tasks. Our method outperforms state-of-the-art methods with comparable scale in all 4 downstream tasks. In this paper, we address the issue of modality alignment in the context of multimodal learning. We introduce a novel approach based on region-based object alignment for the first time, where these objects serve as anchors to bridge modal interaction and alignment. Given the inconsistency between training and inference, we propose a fine-grained alignment method based on the above object anchors and use the similar text for perspective expansion. Extensive experimental results across a variety of downstream tasks validate the effectiveness of our proposed method. Our method seamlessly integrates recent advances in multimodal learning with classical region-based principles, incurring minimal additional computational overhead. We believe that this approach will serve as a valuable guide for future multimodal learning works. Thank you for your listening.